Ladies and gentlemen, here we go on example 6. This is the last one for the first section, and oh my goodness, this one's been fun for me because I record these all in a row and my voice is hurting. All right, so here we have an example of scientific notation. Now remember, scientific notation is the idea that we're taking something times a base 10, but the exponent belongs to that base of 10. So we have a base 10 here and a base 10 here. So remember, our rule is anytime we're multiplying or dividing by the same base, we're actually able to add if we're multiplying or subtract if we're dividing the exponents. Let's see how that works here. A jellyfish emits about 1.25 times 10 to the 8 particles of light or photons in 6.25 times 10 to the negative 4 seconds. How many photons does a jellyfish emit each second? My goodness, I don't know what you're studying about jellyfish, but my brain kind of turned off and fell asleep. But there's a math problem in there, so it actually got excited. That's just me. All right, so what we got to be able to do is we need, there we go. No, there we go. We need to remember down here, this is where I'm at, right here. Okay, remember, a number is written in scientific notation when it is of the form a times 10 to the b, where 1 is less than or equal to a, less than 10, and b is an integer. In other words, you can't have 10 to the 3.4, or sorry, you can have 10 to the 3.4, 10 to the negative 5.6, but you're not going to have a rational. You're not going to have like 10 to the negative 1/3, okay? And you're definitely not going to have irrational and all those kind of fun things. So b is an integer, means no decimals, no fractions, no anything like that. We meet that because 8 is neither a decimal nor a fraction. It can be written as 1, but it is not 1. It is an integer. Negative 4 is neither a decimal nor a fraction. Can be written as 1, isn't 1, it is an integer. And so we have to figure out what we're doing. Well, how many photons does a jellyfish emit each second? Each is the key word here. That means we need to be dividing, or really ratio. It means for every 1 second. Well, I can find that by taking the total particles, because it's asking particles each second. What's after the word each is our denominator, so that means the 1.25 times 10 to the 8th is our numerator, and 6.25 times 10 to the negative 4th is our denominator. All right, I'm sorry, I'm looking up because I had the next part written down as far as what is the answer here. Because what we can do is this would be the same thing as 1.25, because remember that x there means multiply, over 6.25 times 10 to the 8th over 10 to the 4th. And if I separate it out like this and I write it in this notation, well, that just means solve this fraction. And I've got the answer over here. I get, the answer is 0.2 times 10, to the negative, or 10 to the 12th power. Now, we do not, we don't want this because the rule states that a has to be somewhere between 1 and 10, and it can equal 1, but it can't equal 10. In other words, 0.2 is less than 1, but a has to be equal to or greater than 1. So I have to rewrite this as 2 times 10 to the 1st times 10 to the 12th. And now, negative first. Got to think here. Since it's got to be negative because it's actually, this is the same thing as 2 divided by 10, and which can be rewritten as 2 times 10 to the negative 1st. And that's what I did here. Okay. So because this is a fact, that means that this is the same thing as 2 times 10 to the negative first times 10 to the 12th, which means it's the same thing as 2 times 10 to the negative 1 plus 12, which is 2 times 10 to the 11th. And that is my final answer. So I got an answer, but it wasn't in the right form. So I had to keep going. I had to do something else to be able to get it in the right form. So this was the first answer, but it's not the right form. Because of A. So then I had to rewrite what A was, knowing that it's 2/10, which is the same thing as 2 times 10 to the negative first, because that's my rule. To be able to move this up to be multiplication rather than division, I just make the exponent negative. So then I'm multiplying, and then that means it's 2 times 10 to the negative first. I plug that in here. And then I used all my rules for same bases, different powers, add when I'm multiplying, and I got 2 times 10 to the 11th.